Hello friends, welcome back to your UPSC. So today we will start with another topic of geomorphology, that is slope development. So let's get started. So what exactly are the slopes? Slope is an angular inclination of terrain between hilltop and valley bottom resulting from combination of many causative factors like geological structure, climate, vegetation cover, drainage, texture, etc. Okay, so what exactly slope is? See, there is an angular inclination, okay, on of a terrain. There is an angular inclination between hilltop and valley bottom. Okay, so this is angular inclination. It is having some sort of angle. And why this is formed? This is formed by various factors, denudational factors like climate, okay, vegetation, drainage, etc. Now we will see basic elements of slope. So basic slope elements are, first is summital convexity. This is the topmost part. This is also known as waxing slope. Why it is known as waxing slope? Because it grows in height upward. Okay, so this is waxing slope. It is a convex segment and it is found on the hilltop or hill crest, and it is formed due to denudational processes. Okay, so it is formed due to denudational processes. That's why it is called upper wash slope. Next element is free face. It is also known as scarp. Okay, so it is a wall-like slope. Okay, so it is wall-like precipitous slope and it devoids of any debris. See, you can see it is a bare rock because here no debris can stand. Okay, so it is also known as slope of derivation and it is subject to backwashing facility. And because it is subjected to backwashing, what happens in backwashing is, see, like this is standing, this rock is standing, and suddenly floods come. Okay, so this slope from here it will reach here. Okay, this is also known as parallel retreat. So it is subject to backwashing because when the flood come, this slope will be denuded from here and it will be formed here. Okay, so here this is known as parallel retreat. Okay, next is rectilinear element. In rectilinear element is actually a straight linear segment of hill slope profile between upper free face and lower concave element. See, it is between upper free face and concave element. Okay, it is also known as constant uniform regular slope. It is constant and regular because here you can see it is constant. Okay, and it is debris controlled slope. Why? Because here denudation occurs. Okay, debris are formed and here debris can't stand, so here only maximum debris are collected. Next is basal connectivity concavity. It is also known as waning slope. This one was waxing slope, this is waning slope. It is originated due to active denudation, mainly by rainwash, rills and gully erosion. Okay, so this is the end part and it is originated or formed due to denudation. Okay, and it may or may not be covered with debris. So these were the slope elements. Now we will classify slopes. So slope can be classified on the basis of slope element, quantitative classification and genetic classification. So they can be classified in three types. So the first one is on the basis of slope element. So on the basis of slope element, we can see there is single slope or simple slope and compound slope. So single slope is formed only by one element. So simple slope is formed by only one element, such as concave slope, rectilinear slope, free face slope, but it is rarely existing. Okay, and compound slope is consisting of two or more than two slope elements. Like first is convexo concave slope, convexo rectilinear concave slope. So like there are many types of slope. You can form any type of slope like free face, rectilinear concave slope, etc. etc. Next is on the basis of quantitative classification. So quantitative classification is what is the angle of slope? Like is it gentle or is it steep slope? So on that basis we have classified slope on basically eight types. So first one is level to gentle slope. In level to gentle slope, we have level slope from 0 to 0.5 degree, and approximately like uh, almost level slope we have 0.5 to 1 degree, and very gentle slope is from 1 degree to 2 degree. Then we have gentle slope which is from 2 degree to 5 degree, and then we have moderate slope which ranges from 5 to 10 degree, then moderately steep slope which ranges from 10 to 18 degree, then steep slope which ranges from 18 to 30 degree, then we have steep very steep slope which ranges from 30 to 45 degree, then we have precipitous slope which ranges from 45 to 70 degree, and lastly we have wall slope that is ranging from 70 degree to 90 degree. Next, on the basis of genetic classification, like from where it has originated, how it has originated or came into form, we can classify basically on in three types. First is tectonic slope formed by tectonic activities. Second is erosional slope formed by the process of erosional activities by water, air, etc. etc. Next is accumulation slope formed by accumulative process. Okay, when uh, there is co-aggregation of substances of element which form slope. Now we will look into various approaches of slope development. So first approach of slope, we basically have two approaches of slope development. First is slope evolution approach, second is process form approach. So slope evolution approach is based on the temporal aspect. Okay, so it is a time dependent aspect. So not exactly time dependent. It is basically like what was its history and how it has formed. Okay, like what was the past of the slope, what was exactly the slope which has now gradually turned into its present state. Okay, so it talks about the detail of process of formation of slopes over a period of time, and because we are dating the slope, we don't know how much time it may have taken for the formation of slope. See, there may be like sometimes these exogenetic factors may be very intensive, so the slope may have denuded very fastly, and some other time the exogenetic factors may be very slow, because of which the slope may have not denuded so fastly. So we face this is a very major problem which we face in dating the slope development. But under dynamic equilibrium, it is advocated that time does not plays significant role in slope development. Why? Because it is a time independent process, and slope process plays important role in their development. So slope process is mainly the important role. Slope process plays important role. Okay. Now next we have process form approach. Process form approach is based on the concept of direct relation between slope type and slope form and geomorphic processes active on the slope profile, and between the slope type and slope denudation. So it is direct relation of slope type and slope form. Okay. So intensity of denudation is influenced basically by climatic conditions, structure, and rock type. Okay. So how fastly, see, if the rock structure is very hard, then the denudation process will be very slow. Okay, and we will also look into the climatic condition, if there is humid climate or arid climate. Okay, so this is how the intensity of denudation is controlled. Next we have variation in influence of these controlling variable introduce variation in slope. So as we have variation, like if the structure of the slope changes, then the the intensity of denudation or the slope development will change. Okay, if the climatic condition changes, then the process of slope development will change. Like we have same limestone structure, so its denudational activity will be different in a humid climate, and it will be different in fluvial landform. Okay, like where there is water erosion. Okay, and landform development is very sluggish or slow process. Now, so we can conclude that slope form are not controlled by a unique factor, rather they are controlled by several factors like geological structure, vegetation type, rock type, etc., etc. Now, it is generally believed that the geomorphic processes, that is weathering, mass movement, erosion, control the form of slope and their development. But we have a question that whether these geomorphic processes, only a single geomorphic process can control the slope formation, or there are multiple processes involved in slope formation. So on the basis of this, we have two approaches to study the process form approach. First is monoform concept, second is polyform concept. So in monoform concept, it is basically based on the tenet that particular denudational process or process of mass movement produces a distinctive slope form. Okay, so here only one process is involved. Next is polyprocess or polyform process. It says that the slope development is nearer to reality. The study of this slope development is nearer to reality. Why? Because in reality there are only one process can't take place in isolation. Okay, there are many processes which takes place. So here more than one process takes place uh, to form slope. Okay, now the approaches of slope development are completed. Now we will look into the theories or models of slope development. We have three models of slope development. So the first model is slope decline theory, next is slope replacement theory, and the last one is parallel retreat theory. These all these three theories we have studied in our last lecture, so we will quickly review it. So the slope decline theory was given by W.M. Davis, who said that the slope decline theory, this whole process, that is declining process, is time dependent, and he gave this in fluvial landform. Okay, now he said that the waning of slope gradually and progressively decreases in it angle angle accompanied by development of convexity and concavity. See, now with time, the slope will progressively decrease, okay, in its angle. Now, okay, he gave the concept of angle of repose. What is angle of repose? See, this is our slope. So this is angle of elevation, and this will be the angle of repose. So as the slope will decrease, the angle of repose will increase. So with decline of slope, the angle of repose will increase. So this is how the slope decline theory works. This was the huge stage, and with gradual denudation, it has come to its old stage where it is almost plane. Okay, so the slope has declined. Next theory was slope replacement theory, which was given by Planck. In it, what is given? So, in slope replacement theory, what is said that this is the maximum slope. Okay, so this is the maximum slope, and this maximum angle is decreased. How it is decreased? It is replaced by gentler slope. Okay, from below. So this is the steepest slope, and this is the gentler slope. In next stage, it will replace it. Okay, so here gentle slope will come till here, and then in next stage the gentle slope will be here. Okay, the slope B will be here, which is gentle than A, but slope B will also be replaced by slope C, which is much more gentle. Okay, so this is slope replacement, and this result into concavity. Okay, see, this is resulting into concavity. This was first, it was like straight, now it has turned into this, and this whole thing is formed due to tectonic activity. Last one is retreat theory. Parallel retreat theory, it is mostly seen in arid region. Okay, so what happens here is, this is basically when in arid region, when flood occurs. Okay, so it says that the maximum angle remain constant. Okay, the maximum angle will remain constant, and the absolute length of all the parts of the slope will remain constant except for the concavity. Okay, so this is the concavity, and this will not remain constant. Why? Because it will increase in length. Okay, as the concavity, angle of concavity decreases. So what happens is, here what happens is, due to backwashing, okay, due to backwashing, what happens, this slope, this thing, it moves backward. So parallel retreat is happening, taking place. So this remain constant, this length remain constant, this concavity, it is now shifted like this. So the slope decreases. So this was the first position, like this is the first position. Due to washing, the angle has changed. Okay, now the angle of concavity has decreased, but the length has increased. Okay, and next the length will increase more due to more backwashing. Okay, so this was the whole theory about slope development. So that was all for today, guys. I hope you enjoyed the lecture. So let's meet in our next class. Till then, take care and have a nice day.